Hello students, we are making this brief tutorial to understand the workflow with Tanner tools. So in this tutorial, we'll be working with Tanner S-Edit. These are the different tools which comes under Tanner package, and we will be starting with S-Edit 2022 version. Please note that there is one S-Edit viewer also. Here you cannot make the circuit. This is only for viewing the previous circuit. So we will double click on S-Edit. And if you are on a PC which is having the Tanner license already activated, then the software will open. Otherwise, the error message will come. So we are at Tanner tool. This is the launching ground. If you are opening it for the very first time on a new PC, it can give you a message that they want to download some libraries and example files. So please download that. They are very much necessary to work further. On the right side, you may have the property windows also, and rest of the things will be same. Now the first thing we will say, okay, file, new design. So we are starting a new design. It will ask you for a location. So here I am creating a folder called Tanner_experiment. Please do not give any space in the name. So I have given this. So the same will be my library name, and we click on OK. Then it will ask whether to create the library. So we say yes, please create the library folder. So here you can see on the left side the same library is there. Now this library alone is not enough to get started because we don't have all the components, symbols and all. So for that we need to import some existing libraries. So now right click and say add library, and now click on this three dot. And the path for all the libraries will be, you will go to the document folder. Then there is a folder called Tanner 2022. Now here you will go to process. The design folder is having all the designs which are downloaded from the Tanner website. Go to process and click on this generic 250 nanometer. This is the group of libraries which will be needed for our CMOS related experiment. So first library we say devices. Click on this and then click on add. So you can see that this library is added. Now we will have to add few more. Now devices I have taken. If you want to add some logic gates, although in this experiment we don't need them, you can take that. Then what else do we need? We need some devices. So we will go to upper, and first we will say in this go to models. We have to go slightly up, and in this go to standard library. In the process there will be one folder called standard libraries. First take miscellaneous, add it, again add library, and one is this spice plot if you want to plot some waveforms, and one more which is must is spice sources. So these are the mandatory libraries: devices, plots and sources. Any other you can take as an option. Now how to get started in making our schematic diagram? So for that we'll go to cell and say new view. It will ask you that what is the name of your schematic. So let us start making an inverter. So we'll say inverter or inverter 1, whatever name you want to give. So this is there. Now a blank schematic is there. With the scroll of your mouse you can zoom in and out. Now we need to place the components here. So first of all, let us place the NMOS and PMOS. So we'll go to device library, and you can see that as soon as you click on the library, in the left bottom part you will have all the symbols which are associated with this library. And now if you search for MOS, you have NMOS 25, that means which works on 2.5 volt, and you have 3.3 33 version also. So we will work with 25, and if you want to include this device which is shown here, just right click and say instance. Okay, as soon as you do that, the device will be on your computer mouse. It will hover with the mouse, and the details are on the left side. If you want to change any of the details, you can do that. Now I have placed one NMOS Okay, then press escape. Then I take one PMOS, right click and instance, and I take it on top of it, and if you join these two they will be merged also. So I have taken that also. Now I press escape, and now if you want to move a component, press Alt and then drag it. So by pressing Alt you can drag the components, and if you see, the wire remains there. Now I want to attach few more wires, so wire tool is here. Take this and I am making few connections. Now I need few more things. I need a voltage source of VDD, which is 2.5. I need a ground. I need input voltage source also. All these will be available in the sources. So search for VDC first. This is DC voltage source. Okay. Click on instance and you can see this is a 0 volt source. So once you bring it here and change the voltage to 2.5 and say done, and you can see this voltage source is now 2.5 volt. Attach it here. Okay, now I want one pulse source also. Click on voltage pulse, say instance, place the voltage source somewhere here. Okay, and now come to this. Now if you see, this is 0 to 2.5, which should be there. Okay, it is a 200 nanocycle total time period, 100 nanosecond up, 100 down, 5 and 5 are rise and time, fall time. So click OK. So now your voltage T pulse is also there. If it is not placed in first instance, you can do that by confirming. This is 2.5, click done. Voltage name, disable. Okay, fine. So let us make it 2.5 to ensure. And now it is there. Okay. If you want to drag again, Alt and drag it. Now we need ground. Ground will be available in miscellaneous. So search for GND and instance. One ground I'll take here, one ground I'll attach here. Now take the wire tools and complete the connections. So this one goes to ground, one more. So V input is connected and VDD is connected. All the connections are done. Now we will attach input port and output port. This is our input port. You can keep it V in or you just change it. This is our output port and we call it V out. If you want to label some other nets, then you can do that. So labeling will be available here. So now we are done with the connections. Now in LTSpice, what used to happen that you will just simulate it and then you will put the cursor at some points and it will plot those voltages. Here you have to mention those probes in advance. So here in the print plot, search for print. You want to print voltage, so last one is voltage print. Right click instance, and if you want to print output voltage, then you click here. Okay, anywhere you attach it. If you want to print input voltage, press R. It can rotate also. So these are the 2 points where we are going to print voltage at this point and print voltage at this point. So now our schematic is ready. You just save it. If you want to see that what is the spice file for that, then you can click on this and it will show you the netlist file, which is also called the spice file. So this is the netlist of all the connections that we have made. Okay, we can just close it, come back to the schematic. Now we have to set up the simulations. So for that we will go to setup simulation. So first of all, go to general. If you want to print voltage, enable this to true. If you want to print current, enable this to true. If you want to print charging, so this is our first step. Now we have to include some libraries also. So left click here, and here we have to add by using this new library. Here these 3 dots will come. Click on this and we have to go to the same path. we have to go to documents, Tanner. Now we will go to process, and in general purpose go to models. Okay, please remember, go to models, go to spice and choose this library 250 nanometer. Okay, take this library and on the right side, out of all the options, select TT. Now I have to include two more libraries, again same path. Okay, documents, Tanner, process 250, models, spice, and this time take global. Now once you have done this, for this select signal 3. Now one more time I have to take the library. So again the same path, documents, Tanner, process 250, models, spice, again global, and this time with global we will say pro MIS. So these are the three we have done. So our library is set up, our waveform probing is set up. Now I say I will do transient analysis. What is our stop time? So 200 nanometer is our total time. So maybe I'll run for 3 clock cycles. So 600 nanometer, start time 0, maximum time steps 10 nano. You can take less also, that is okay. So once all these things are done, click OK. Here is the run button. Now we run. So first your schematic will be converted into .sp file, which is spice file. So here tSpice, which is another tool, that has opened and it has tested whether your connections and all are correct. Okay, so once this is done, if there is any warning, they will tell here, and after that it will automatically open the third tool, which is Tanner waveform viewer, and you can see my input and output waveforms are here. If you want to separate them, you can click on this. So this is my input, this is my output. This is how you can get started with Tanner tools. This was a very brief tutorial. So whenever you start working on any schematic, these are the initial things we have to set up. I hope this was useful. Keep learning. Thank you.